This video is on the objective determine the p-value for a hypothesis test for the difference between two means. And this is with the population standard deviations known. Right? So if that's the case, you're going to be, your test statistic will be a z-score, and you're working with the normal distribution instead of, the student's t-distribution. And this is the second video on this objective. Hopefully you've watched the first one as well. And let's take a look at the problem. Now, if you want to see more on the objective, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you out. Alright, so here a team of archaeologists is re-examining a site where two additional sets of artifacts have been discovered. The sets of artifacts are in two separate areas of the archaeological site, where each set is adjacent to artifacts that were discovered in the past. Since both sets of artifacts were discovered at about the same time, years after the first examination, the members of the team would like to find out whether the population mean age of the artifacts in set A is different than the population mean age of the artifacts in set B. Using information from the first examination of the site, the members of the team assume that the population standard deviation of the age of artifacts found in set A is 135 years. All right, so there's like sigma 1, right, the standard deviation of population 1, the objects from set A. And the population standard deviation of the age of the artifacts found in set B is 119 years. So this is sigma 2. The team takes a random sample of the artifacts and finds the ages of each artifact using radiocarbon dating. The results are provided in the table below. Alright, so from the set A of the site, they took 71 artifacts, and the average age of these 71 artifacts was 2,726 years. From set B, from the other part of the site, the other location in this site, they took 65 artifacts, and the average age of these 65 artifacts was 2,692 years. So we're asked to let mu1 be the average age, of the artifacts in set A for all the artifacts, the entire population, right? And mu2 be the population mean age of the artifacts in set B. Now you could find this on your own, right? We've seen how to find the test statistic for this, these tests of the difference between two population means where the population standard deviations are known, right? A z-score, but they're giving it to us here. The test statistic is, z equals 1.56. They're asking, all right, now that you have the test statistic, what is the p-value for this statistic, for this hypothesis test? And they're asking us to, I could use a calculator if I wanted, but they're asking us to, compute your answer from the following table of z-scores. All right, so I'm going to draw some pictures. Well, first I'm going to establish the hypotheses. All right, I want to know, is this a one-tailed, right-tailed, a left-tailed, or a two-tailed test? Because depending on what kind of test you have, that'll tell you how you're going to calculate your p-value. All right. So reading back through this, let's identify the claim or the statement being tested. In the third sentence, and I know you're not seeing it right now, I'm just going to read it out loud again. The members of the team would like to find out whether the population mean age of the artifacts in set A, right, that's mu1, this is the average age of the artifacts in set A, is different than the population mean age of the artifacts in set B, that's mu2, and being different is, being not equal. So this is the claim, that the thing being tested, right, that the average age of the artifacts in set A is not the same, is different from the average age of the artifacts in set B. Now, an alternate way of saying this is that mu1 minus mu2 is not 0. Right? Okay. And then once a claim is set up, you can then also set up your hypotheses. Now this does not involve equals, right? So this is going to be represented by the alternative hypothesis. And then the null hypothesis is the opposite statement, right? And this always involves some sort of equality. And this is what's being assumed. You assume that the null hypothesis is true, and then see if you reject that later or not based on the sample evidence. So we'd be assuming that the average ages are equal, that the average age of the set A artifacts is equal to the average age of the set B artifacts. And then from the way the alternate hypothesis looks, the alternative hypothesis, you can tell what kind of a test it is. Right. Now this is a parameter is not equal to some value, and if that's the case, you have what's called a two-tailed test. Right. If it was just greater than, it'd be a right-tailed test. If it was less than, it would be a left-tailed test. But it is a two-tailed test. All right. Now there's some other stuff that'd be involved, but I'm going to skip to right. They gave us the test statistic and asked us to find the p-value, and that's all. So the test statistic for our samples was this z-score. For the difference between our sample means was this z-score. They said it was 1.56. So I'm going to draw a picture here of the z distribution, right? The standard normal distribution. Right, symmetrical bell-shaped curve. Underneath the peak is a z-score of 0, and our test statistic comes in at 1.56, which is to the right of 0. Right? 1.56. Now, for the p-value, if this were a right-tailed test, the p-value would simply be the area to the right of my test statistic. If it were a left-tailed test, the p-value would simply be the area to the left of my test statistic. But being that it is a two-tailed test, the p-value, again, since this is to the right of the mean, I'm going to take the area to the right of my test statistic and then double it. Double it. Or you could say take the area to the right of positive 1.56 and then look at the area to the left of negative 1.56, right? Because this is symmetrical, those should be the same area, and put those together. So either way, you get the same value, right? So the p-value, remember, is this area, right? The area to the right of my test statistic, because it's right of the mean. If it was to the left of the mean, I'd just take the area to the left of the test statistic and then double it. So it's this area, times 2. Again, two-tailed test. All right, so now we're asked to use that table, right, that z-score table to find this area. So let me show you that. So remember, when you look at these numbers, these z-score tables, the numbers in the z-score tables tell you area to the left of the z-score. All right, so my test statistic was 1.56. Right, so I'm going to this row with 1.5, and then this column with 0.06. So the 1.5 row, the 0.06 column. So a z-score of 1.56 has this area to the left. Right, this is 0.941. 94.1% of the area under the curve is to the left of my test statistic. So I'll write that out. All right, so this area here, from 1.56 all the way to the left forever. Okay, this is 1.5 area under the curve all the way to the left forever. That area is 0.941, 94.1% of the total area under the curve, according to that table. So the area I want to find, right, this area to the right of my test statistic, is just 1 minus that. 1 minus 0.941 would be 0.059. Right, so this area is the area to the right, and again, for p-value in a two-tailed test, I'm going to take this area and double it. And if I double 0.059, I'm getting 0.118. Right, 5.9% doubled would be 11.8%. And here is the p-value of my test statistic, the p-value for the test. And then I would compare this p-value to my significance level, whatever alpha is. Now, they didn't mention anything here because that's not the point of this. The point of this problem is to just find the p-value. So from this table I got a p-value of 0.118. You know, again, using the fact that it's a two-tailed test. Wonderful. And again, please read through the answer explanations and stuff, right? And hopefully watching me draw some pictures to go over this, looking at the more instruction if you need to, reading the answer explanations when they come up. Hopefully all this stuff helps you when you go about doing this on your own. All right? And thank you very much for watching.